here we're going to graph the quadratic function y equals a second degree function in x. Y equals -3 parenthesis x plus 1 close parenthesis squared plus 3. We're going to graph that, and we're going to carefully list the vertex, the axis of symmetry, the domain, and the range, the vertex, I already said vertex, and the y-intercept. Okay, solution, step 1. Let's compare this to the standard quadratic function y equals a parenthesis x minus h parenthesis squared plus k. When we make a comparison, we can identify the a value. The a value is -3. When the a value is negative, that means that this is going to be a upside down parabola. I call that sad face parabola. That's because the a value is a negative number. It's -3. Now step 2, let's find the vertex. We know the xy coordinate for the location of the vertex is hk. We can identify h and we can identify k just by looking at and comparing the two equations. The number that's being subtracted from x is the h value. Look at the y equals -3 parenthesis x plus 1 parenthesis squared plus 3. The number in that being subtracted from x is a -1. It's x minus a -1. So that means that the h value, the number being subtracted from x, is -1. And then the k value is a number that's being added at the end. That's +3. So the ordered pair hk equals -1, 3 is the location of our vertex. Step 3, find the axis of symmetry. In a happy face or sad face parabola, it's called a vertical line x equals h. It's a formula for a line. It has to be x equals a number. You can't just put the number. You have to put x equals a number because it's an equation. So here h is -1, so the axis of symmetry is x equals -1. So that's the equation of the vertical line that cuts the parabola exactly in the middle and helps us to do the sketch. Step 4 is where we're going to find the y-intercept, and we do that by first taking the given equation and writing it out. Y equals -3 parenthesis x plus 1 squared plus 3, and then let x equal 0 and solve for y. So we have y equals -3 times 0 plus 1 squared plus 3. So 1 squared in parentheses, that's just 1. And simplify, you get -3 plus 3, which is 0. So the y-intercept is the ordered pair xy equals, now wait a minute, we started by saying let x equal 0, so the x coordinate is 0 and the y coordinate is what we ended up with, y equals 0 at the end on the last line. The ordered pair xy for the y-intercept is the ordered pair 0, 0. Okay, step 5 is where we start the sketch. We do the sketch. So use all the information that we gained in steps 1 through 4. Here's our y-axis, here's our x-axis. And okay, now we're going to put the axis of, well, the vertex, -1, 3 is located here. And then the axis of symmetry is the vertical line x equals -1, identify it here. And now the y-intercept occurs at 0, 0, so locate that point. And coming, the y-intercept, 0, 0. Coming from that point, we want to come down from, okay, and it's sad face. We know it's sad face from step 1. Come down from the vertex and move through the 0, 0 point. Then move the exact same distance on the other side to -3, and -2. So you have a perfect symmetry on both sides of that dotted line. So this is the graph of the equation y equals -3 times x plus 1 squared plus 3. Now step 6, you don't forget to list these things. Vertex VHK is -1, 3. Axis is the equation x equals -1. The domain, well, look at the graph. The domain are all the x values. Every x value from -infinity to +infinity will have a point somewhere on this graph as it opens up and moves downward. But the range, that's different. All y values, the smallest is -infinity, but they don't get any higher than 3. They get right up to 3 and stop. There's actually a point at y equals 3 and no higher. So it's ordered pair -infinity up to 3, boxy bracket, include the 3. And of course the y-intercept is the ordered pair xy equals 0, 0.